What is a quadratic equation? A quadratic equation is an equation where the degree is 2, meaning that the largest exponent is a 2 when the equation is in standard form. So as you know from last week, standard form of a quadratic equation is ax squared plus bx plus c. So this is the expression. Now that we're dealing with equations, we would have this expression set equal to y. Or when it's written in function notation, it would be set equal to f of x. You may see a quadratic equation in 3 different forms. Standard form is like we just said, ax squared plus bx plus c. So that's where basically your a, b, and c are numbers, and it's just an expression. You may see your quadratic in factored form. You can recognize that it's in factored form because you see parentheses. So this is what we worked on last week. There's another form called vertex form, where basically you have one of your sets of parentheses is going to be squared and you have numbers on the outside. You just have to be able to recognize that something is a quadratic by basically counting the number of x's. So in this case, we can see that this is x squared. In factored form, I have 2 x's, which means if I was to multiply this, x times x would give me x squared, again giving me a degree of 2. And in this case, if I wanted to multiply this, this really means x minus 3 times x minus 3. So x times x is again x squared. Now that we have an x and a y value with an equation, we can actually graph on a coordinate plane, again, because we have the x and the y value. So this is what we call the parent function of a quadratic equation. And it's basically the most basic quadratic that we can graph. As you can see, the shape of this is a U shape, and we call this a parabola. So just like any graph, we can list the domain and range and the intercepts. So domain is a list of all possible x values. So if I was to look at this graph, and one thing I'm going to kind of add some arrows in, this is continuing in the upward direction. So my domain, if we remember, we read from left to right. So because this graph is going forever and ever up and to the left, and forever and ever up and to the right, my domain starting on the left would be negative infinity. And it's going to continue all the way to the right. And we read that as positive infinity. Okay, my range is all my possible y values. So I read range from bottom to top. So notice my graph only starts here. So my y value at my lowest point is 0. So I would start at 0, and I'm going to use a bracket since it's actually touching 0, and it's going to go up forever and ever, so that would be to positive infinity. Okay, in this case, this parabola has one x-intercept. So remember, the x-intercept is where our graph touches the x-axis. So in this case, our x-intercept is at the coordinate point 0, 0. Our y-intercept is where our graph is touching our y-axis. And again, same thing, our y-intercept is also at 0, 0. So this is for the parent function, but you can have lots of different graphs of parabolas. So let's just do one example together. The domain for this graph, again, we're reading left to right. Domain is all our possible x values. Because this is going all the way to the left, this is going to continue, and all the way to the right, our domain would again be negative infinity to positive infinity. Our range, in this case, again, we're reading bottom to top. Okay, we would start down here. Now in this case, I can't exactly see where this graph starts. So I'm going to do a little estimate there. Okay, this is at -6, and it looks like it's almost right in between. So I'm going to estimate this and say that my graph starts at -6.5, and it's going to continue to positive infinity. Okay, now the last graph had only one x-intercept. This one is a little bit different because, as you can see, our parabola can cross the x-axis at more than one point. So in this case, I'm crossing the x-axis at +2, and I'm also crossing the x-axis at -3. So this quadratic equation would have two x-intercepts. Okay, it would have an x-intercept at -3 and +2. Okay, my y-intercept, again, it's the same as before. It's where we're crossing the y-axis, and that looks like that's at the point 0, -6.